In this lesson, we're going to be doing applications of radian types of problems. This one's going to be involving areas of sectors. So the area of a sector is similar to an arc length, where you have basically just a fraction of a circle. So you're just talking about kind of a pie slice, pizza slice. You want to know what the area of that thing is. So it's just going to be area times a fraction. So either you have this angle measurement either in radians or in degrees. If it's in radians, it's going to be a fraction radian measurement out of 2 pi. If it's in degrees, then it's whatever the degree is out of 360. So otherwise, it's still just pi area, pi r squared, times your fraction, pi r squared times your fraction. So there are some benefits to if it's given in radians. There are some other formulas for this, but you really don't need to know that because you can just treat them exactly the same. And the nice thing about these formulas are they're really the same when you deal with arc length, because the arc length is just circumference times fraction. So the good thing is it's very consistent, and you're not remembering a new formula. So if we're doing this one, we're talking about 5 pi over 6, which is just going to be some fraction of our area, and we're going to use the radius to figure that out. So our sector is going to equal pi times 29.2 squared times our fraction, 5 pi over 6 out of 2 pi. And we're literally just going to plug it into the calculator. Just kind of a little side note, that pi is always going to cancel that pi if you're in radians. If that's worth doing, great. If not, just put that whole thing into the calculator. And we are looking at roughly 1,116.1 meters squared. Alright, so the main thing is, are you okay with the setup on this? So that's example 1. Example 2 is going to be another problem kind of similar, except this time they give you a sector area. They tell you it's 50 inches squared and the radius of this circle is 5 inches. Then what is the arc length of the sector? So you're looking visually kind of at, I don't no idea how big this is going to be in relation to the whole circle. So we'll just make it something like that. That if this piece equals 50 inches squared, and you have a radius of 5, so it's kind of like you know the area of the pizza slice, but what's the crust? All right, so we're looking for the arc length. So we'll start with the sector. So we know that the sector is going to be, so this is going to be 50. We're going to sub that out in a second, but we have pi r squared is going to be, let's do it in radians. So radian over 2 pi. Okay, so we know what the radius is, we know what the sector is, so what this is going to help us is it's going to give us our radian measurement. So then we'll take that and kind of we're going to take our radian measurement and then we'll start our whole problem over, except we'll know the radian measurement and the radius and we'll be looking for the arc length. So we'll sub things in. So we have 50 equals pi times 25, because it's our radius squared, and then times, we don't know, the radian out of 2 pi. Okay, so we got a little bit of stuff that we can do to simplify here. The pi here is going to cancel the pi here. The 25 divided by 2, let's just kind of leave it alone. So we have 50 equals 25 over 2 times this radian measurement that we don't know. And we're going to get rid of this, multiply both sides by its reciprocal. All right. So then the 25 and the 50, that's going to make that a 2. It's going to make that a 1. So your radian measurement is 4. Now radians typically have a tendency to have pi in them, but this is as if pi's kind of been multiplied through, and this is what you have. Remember that all the way around the circle is 2 pi, which is 6.28, and so we're less than that, but we're definitely at a big chunk, so my picture's not even close. So what would be the crust of this? So what would the arc length of this thing be? We'll start the problem over. So if we do the arc, and since this is in radians, we're going to take 2 pi r radian measurement over 2 pi. So again, very, very similar feel. That's what I like about these formulas. Doesn't change too much. We know the radian measurement, we know the radius, we just don't know the arc. Let's plug things in. So the arc is going to be 2 times pi times 4. Our radius was 5. Our radian, our angle is 4. And then we'll do some math here. And the nice thing about radians is 2 pi's cancel out. So then our arc is a very nice 20. And label was inches. Okay. So that was a problem, kind of mixing them all together. So we just started off with what we knew, solved for a missing piece, and then that missing piece we were going to use to kind of continue to finish off the problem, to find our arc. There's a good chance that you'll probably want to leave these things or do these things with radians, just because some pi's will cancel out. If you don't, you're going to have a degree over 360, and the 360 is definitely not going to work well with the pi, so then either you're going to have to deal with all the decimals in the calculator, or you're going to have to leave everything in terms of pi, and then eventually things will cancel themselves back out. But starting in radians is going to be probably a cleaner path than starting in degrees when you work some of these types of problems. All right. Okay, but that is a couple problems involving areas of sectors.